Okay, so today we will speak about how can we see the results of any model or any geotechnical model. Here in this model, we have slope and two tunnels, and this surface is the infiltration surface for the rainfall water. So if we want to see the results, of course, we come from here, then we press here. This is view calculation results. We have to judge the results if it's true or not, okay? So if we go here, from here, we can see this is the model. This is the total displacement. Of course, when we see any model, we have to look at this model to, for example, choose the most critical surfaces we want to judge, the most critical places we want to see in this model. According to this model, here we have these two tunnels, okay? And here we want to see what is the most critical part of this model. First, we have to determine what are the parameters which we need from this model. For example, I need the displacement mu z. Also, maybe I need the pore water pressure. Also, I need the saturation because this is the model for the rainfall and we have water, so we can know what is the saturation percentage in this model. Also, we can know what is the stresses here, the effective stress, sigma zz, for example, or the Cartesian stress. This is the total stress. And we all know the difference between the Cartesian effective stress and the Cartesian total stress, because the total stress is the effective stress plus the water, okay? So when we see such a model, we have to determine what we want to take from this model. Because this model is rainfall model, so we need, for example, the settlement, the water pressure, the saturation, the suction. Also here, from here, we can see what is the suction value and also the stresses, okay? So I will maybe do such a method to get the results from such model. For example, first we can take from this, okay? I need like to take a section in the middle of this part, in the middle. So I take this is a section first, okay? If we want to disappear these cluster boundaries, just like this, okay? So in this section, we have the two tunnels. Then we have like this. It appears that according to the legend here, and this is the settlement values, and it appears that we have like here maximum value, it's positive value, and minimum value is negative value. So we have positive values and negative values. So we can say that the positive value, it it's like swelling, because here we are speaking about the total displacement. The total displacement may be in, when it will be positive, it will be like swelling, and when it will be like negative, it will be like settlement. So I will take a section. If we want to look at this section, where is the most critical place to take a long section in this? Maybe it will be here, because here is the maximum settlement. So I can take a section here in this area, okay? So I take a section here in this area, which is what? This area is specifically where the rainfall water, okay? I take a section here, then it gives me like this. Again, when we want to disappear the cluster boundaries, we can go from here and take it. I don't need to see the cluster borders again. So I disappeared, okay? Then I take this. In this also we have positive value, which is a swelling, and negative value, which is settlement. And here we have also to mention that we are still talking about the total displacement, okay? Then I can take from here. Here it will give me the data, which is x, y, z, mu z, which is the settlement, which is my target. Then I will just get again here. We have here y, x, z. So what I want when I get here, into the detailed data, how can I know if I want x or y or z? I can know from here. From it will be, maybe it will be a bit different. Okay, continue. It's because it's correct version, so maybe it will give me such problems. Okay, so because we have x, z, and y, we have three main different x's. So when we want to choose the settlement, I have to choose this settlement will be in which direction. This settlement should be in x or y or z. This is the water load. Why there are water load? Because it's like rainfall. Okay, so we get again to the settlement mu z. Okay, then I will repeat the previous issue. Okay, this is in the middle. Then, because I know I have to cluster borders I don't want, then from here, because this is the most critical place, so I take a section here in this area. Then when I want, I will cluster borders and I want it. Okay, so this is in y direction. Okay, so this is the settlement mu z, and the swelling also mu z in y direction. Okay, but there is no settlement. Why there is no settlement? Because there is no negative value. So if there is no negative value, it's not settlement. Uh, it's just about swelling, because here we have in the upper part here, it's just like a field soil. So when there is a rainfall on the field soil, this will be like swelling, because this is the field soil. The field soil will be influenced by the rainfall as a swelling, not as a settlement. So this can give us a reason why here these values, the maximum value and the minimum value, is just like positive, because it's just swelling. Okay, then we came here. I determined I will also open the Excel sheet to take the data from PLAXIS to the Excel sheet. Okay, so here I will determine the y, and then I go copy here. Okay, paste. Then here we have to get the data like this. I will like this. Then I will say that this data have to be like general. Okay, when I take it like general here, it has been changed. Then the first two I will delete it because I don't need it. Then y, this will be in meter. Okay, then I will repeat this for music also, and then I will take it here. I will paste it here. Then I will also see I want it to be general. Okay, then I will delete these two. Then this is music. Okay, but here I have also to mention that music in general, because this is like swelling value or settlement value in general, it will be in millimeter, not in meter. Because when we write like scientific research, when we want to judge the settlement or the swelling value, we take it in millimeter. So here I will write music again. I will say like you have to make it like this, multiple by 1000 because it's millimeter, then just like this. Okay, then I will make the chart. Okay, here I will choose what data I need. Okay, then here I will say this is, for example, swelling, for example, just like an example. Okay, then again here I want like this, and I will determine the settlement in millimeter, not in meter. Okay, then accept. Okay, here we can see this is the data. Okay, then because this has to be in the right format when we're writing like report, when we're writing like scientific research, when we're writing like a report for any project, we have to make the format. Okay, so